What did you write for the first one? I cannot see. So small.
The first one.
Yeah.
The surface area is more and therefore increased frequency of successful collisions. Surface area increases and therefore increases in
The
frequency.
surface area is very large,
Yeah.
not small.
No, I said surface area increases.
Oh, okay. Can. Large surface area, more frequent
Effective collision.
collision between particles. Okay. Explain why most the concentration of reactants decreases. So lowest. Okay, so correct. Concentration.
Of reactant decrease.
Yeah.
So lower
Yeah.
frequency of successful collision.
Increases with time. Okay, can. And you can also say less particles per unit volume. So just the explanation why the rate of reaction has exposure could decrease rather than
Heat.
decrease.
The heat
Heat
release
release,
will
increase
increase
temperature. Yeah,
temperature of reactant and gain the thing will gain KE, so more frequent effective collision.
yeah, correct. Heat release will increase temperature. Okay. Um, Particles gain more kinetic energy and more particles achieve activation energy. All right. And then more collision. Right. Okay.
Number put
Plaque.
flower.
Plaque. Sawmill also can.
What's a sawdust?
Sawdust. Sawdust.
Ah,
Okay.
what's a sawdust?
Sawdust, after you do the wood, you cut
Ah,
the
the
wood,
little bit of wood one.
yeah, the all the dust that is flying around.
The only reason I say flour is because I see the people they spit fire out, they use flour.
What's that?
The street performance one in China.
In
They
China, they
just
do what?
they,
Sorry?
s- they have flour in their mouth and they just spit it out with the fire.
Oh, that one. Okay. All right. This one, right? What you do is take two test tube. Okay. You put simple experiment. You put 10 5 cm cube of sulfuric acid. The first one you put 1 gram of zinc pieces. The other one you put 1 gram of zinc powder. And then you see which one dissolves faster. Get it?
Yeah.
So prepare 2 test tubes, each with 5 centimeter cube of sulfuric acid to 5 degrees Celsius. 1 gram zinc pieces. Observe. The One with powder will dissolve faster. Okay. Okay, are you done?
Almost. Okay.
All right. Okay, today we're gonna talk about another subtopic. It's called equilibrium. Have you learned it in school yet?
No. We haven't even finished the product reactant activation energy one.
Okay. But you can understand?
Yeah. We are still learning the mountain one.
Mountain one. What do you mean
This
the
one.
mountain?
Eh. Oh, this one. We're still learning these two.
Sorry? You mean the rate of reaction,
Ah, yeah. The diagram,
the
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 draw one.
diagram. Okay. Now some reactions are reversible. What does a reversible reaction mean? Okay. I put in a closed container. Usually this one involves gas. Okay. And I put hydrogen gas and iodine gas. Okay. So okay, what do you think is a product?
H2 plus I2 ah. Uh,
Second.
2HI.
Yeah, correct. Okay, so what happens is at first there is no hydrogen iodide. So at
Yeah.
first it will only go forward. The reaction will only go forward. Okay, now what happens here is after a while, the hydrogen iodide, when there's at first there is no hydrogen iodide, so hydrogen iodide cannot react. But after a while, this one will become more and more and more, right? So this also starts to break apart and form back hydrogen and iodine. So when hydrogen and iodine form hydrogen iodide, this direction is called a forward reaction.
Uh, forward what?
Forward reaction, okay? Or it's called shifting it to the right.
Okay.
Okay? Now, when hydrogen and iodine break apart, this direction is called the reverse reaction
Reverse
or,
reaction.
or backward reaction.
Oh,
Or it says you're shifting it to the left.
okay.
Understand?
Yeah.
Okay. Now, first, because there is a lot of hydrogen and iodine, of course, more forward reaction happen at first. Correct or not?
Yeah.
After a while, there's going to be less and less hydrogen iodine. So it's more reverse reaction. So you go forward, backward, forward, backward, forward, backward. Okay. Now, after a while, they're going to be, so maybe at the start here is 100%, here is 0%. Okay. After a while, this one becomes 90% and some 10%. Okay. Then after a while, it becomes 50%, 50%. Then after a while, it changes again to become, let's say, 70 and 30. Okay, so it's just switching forward, backward, until it becomes 70 and 30. Now, what happens is when it becomes 70 and 30, after a long time, it doesn't change from becoming 70 and 30. Okay, it doesn't change from becoming 70 and 30. All right, so that means there is still forward reaction, there's still reverse reaction, but it maintains at 70-30. So when it maintains at 70-30, it means that this has reached an equilibrium or a dynamic equilibrium. Okay, so the question will always ask you, few things that they will ask you here. What does this symbol mean? This symbol means the reaction is reversible. The second question they will ask you is, what is the definition of equilibrium? So two things. The rate of forward and reverse reactions are equal. That's the first part of the definition. The second part there is no overall change in the concentrations of reactants and products. That means if it's 70%, 30%, it's staying 70% and 30%. It doesn't change anymore. Okay? Do you understand? Finish writing down already?
Yeah.
Okay. So this is the definition. When they ask you definition, you must write this whole thing. It's a 2 mark question for definition. It's this and this. And then they usually ask you what's this symbol mean? And then it's reversible. Okay? All right. So what affects equilibrium? Okay, let's compare it to, so equilibrium is also known as what is the yield? Yield means how many percent is the product. Okay, so let's compare yield and rate. Okay, what are the 5 factors that affect rate?
pH,
Huh?
concentration,
Ah,
temperature, wait, concentration, temperature, pressure,
okay.
catalyst,
Pressure, catalyst.
particle size.
Okay. All right. Yield can be affected by concentration, can be affected by temperature, can be affected by pressure, but it's not affected by catalyst or particle size. And the way it's affected also different.
Okay.
Okay, sure. Okay. So like this, okay, this is an example of a reversible reaction. Okay. Now, something very important is the state because different things affect it differently. Okay. So we're going to talk about pressure first. Okay.
Okay.
All right. Now, what happens is how many moles of gas do you see in the reactant?
4.
How many moles of gas do you see in the product? Oh, sorry, I forgot to balance it. Here got two. So, the one here got two. Can you please write the two here?
Yeah.
Okay. Product got how many moles of gas?
2.
Okay. Okay. So now, if I put high pressure, okay, high pressure favors the side with less moles. Okay. All right. High pressure favors the side with less moles. Okay. Now, so if I put high pressure here, okay, if I put high pressure here, for example, I put 200 atmosphere. This is a unit of pressure, atmosphere. If I put 200 atmosphere, it's high pressure. Do you
Yeah.
think it will go forward? It will favor the product or favor the reactant
Favor the product.
product? Okay, so it will shift the equilibrium forward. Okay, so how you write is, if high pressure is used, the yield of ammonia increases. Why? There are less moles of gas at, you can say, forward reaction. Or you can also say the phrase, the equilibrium shifts to the right. Okay, can you understand?
Okay.
All right. Can? Ready? Okay, now let's go back to just now that equation.
Okay.
Okay, if the pressure is increased, what will happen to the yield?
Stay the same
Yeah. Okay, why?
because the moles of the reactant and the product is the same.
Correct. Okay. But will it affect the rate? The rate will increase. The yield, no change, but the rate will increase. Understand? Because high pressure, high yield.
Okay.
Now remember just how we wrote this equation? Okay. Are you ready? Okay, now let's say I write this at the back. What does this mean?
Ac-
It's like,
activation. No.
no, no, no. What does this mean? Hmm? Do you remember? Go and look at your own notes. See, what does it mean? Hello, oi. What does this mean? That means this forward reaction is exothermic. Remember?
Uh-huh. Oh, positive means exothermic, negative means
No, negative. Negative. Here I put negative. Negative is exothermic.
positive is endothermic.
Yes. So if the forward reaction is exothermic, then the reverse reaction, this direction is what? This way is what?
Left.
Yes, I know it's left. If the forward is exo, the reverse is N.
Endo.
Understand or not?
Uh-huh.
Reverse reaction is endothermic. Get it? Get it?
Yeah.
So if I increase the temperature, okay, now here's the thing, listen carefully, high temperature, high temperature loves endothermic reaction. Okay. Okay. So what happens when I increase the temperature? If I increase the temperature, will it favor the forward or favor the reverse?
Reverse.
Correct. So if I increase the temperature, the yield of ammonia decreases. But if I lower the temperature, it will favor what? Low
Exo.
temp. So the yield of ammonia increases. Can I understand or not?
Yeah.
Mm. All right. Okay. Can I go to the next one? So far we have done temperature and we have done pressure. But if I have high pressure, what will happen? What happens to my rate? Sorry, high temperature, what happens to my rate?
High temperature, rate increases.
High temperature rate increases. But if high temperature, the yield decreases. Wow, headache like that. So which one should I do? Now I'm trying to make more ammonia. Okay.
Yeah.
Here's the problem. I want to make more ammonia. Why? This process is called Haber process. Haber process is the process that we do in the industry
Oh,
where we
Fritz
take,
Haber.
yeah, to make ammonia.
That guy
We
is.
want lots and lots of ammonia. Okay, so what we do is, alamak, yeah, hold on, my thing is, wait, hold on. Without. Okay, we already know that the forward reaction is exothermic, right?
Yeah.
Okay. So should I use high temperature or low temperature to get a high yield, high amount, high percentage of ammonia?
Low temperature.
But if I do low temperature, my rate is too low.
High temperature?
But then high temperature, my yield is too low. So they compromise.
Oh my.
Okay. So they use 450 degrees Celsius. You guys are not living it, right?
No, it might happen.
Okay.
My black color, do you see it?
No. We use 450 degrees Celsius. Okay? Because the temperature is high enough to get a high yield, a high rate, and high enough to get a high yield. Okay? Can? Now,
Okay.
should I do high pressure or low pressure?
You should do low
What do you
pressure.
think?
Low pressure.
Low pressure will favor where?
Forward. No, low pressure will favor the one with more mole.
So what should I do? High pressure or low pressure?
High?
So we do 200 atmosphere. Will it have high yield also? High pressure, will it have high yield, also high rate?
High pressure?
Will it also have high rate?
Yes.
Correct. Okay, so it's a good thing. 400, 200 gives us high pressure, also high yield. Now, what happens is in Haber process, we use a catalyst. The catalyst is iron. Now, iron doesn't increase the yield, but it increases the rate. That's why we use iron. Okay? Can I understand? Okay, now this
Yeah.
is what happens in a reaction. If you add more nitrogen, which do you think, if your concentration of nitrogen increases, which one do you think it will favor, forward or reverse?
What?
If I add more nitrogen, if I
Yeah.
add more nitrogen, do you think it will be forward or reverse? It will
For
favor the forward or the reverse.
forward.
Okay, because they want to try and get rid of the nitrogen. So the more nitrogen I add, it will favor the forward. Now, what happens is, what do you think happens if I take away hydrogen? If I take away hydrogen, it will favor forward or reverse?
Take away hydrogen.
It will favor the forward or the reverse.
Reverse.
Yeah. So we shouldn't take away hydrogen. We keep adding hydrogen. Now, what about ammonia? What should we do? Should we add more ammonia or remove ammonia to make more ammonia?
We should add. We should remove
Yeah.
ammonia to
Correct.
make more
Okay, so
ammonia.
that's what we do in the experiment like this. Okay. So we pump in nitrogen and then we pump in hydrogen. Okay, and then we put it into a chamber that has iron like that, iron beds. Okay. All right. Now what happens is after the reaction, you will have a mixture. So this is iron at 450 degrees Celsius and 200 atmosphere. Okay, you will have a mixture of nitrogen, hydrogen, ammonia. What we do is we cool it down. Ammonia becomes a liquid first, and then you remove the ammonia. And then the nitrogen and hydrogen that didn't react, you go and recycle again so that you will always have extra nitrogen and hydrogen inside. Can you understand?
Yes.
Okay, can? All right, let's try some questions. So this is called Haber process. Okay, it's called Haber process. Can? Okay, I'm going to
Yep.
give you, it's a two-part question, okay? I'm going to give you part one and part two. Okay, this is part one. Okay, and this is part two. Do you know what to do?
What?
Okay, send you part one and then part two. All right. Okay. Part one is in your WhatsApp also. Okay. In case you want to scroll up and down. Okay. So you cannot say matter, okay? You say gas, no, uh not actually matter is no substances can enter or leave. Okay. All right. Rate of all reaction equals concentration of what? Concentration of what? Why you write halfway on? Zihua, you're muted.
Concentration of reactant and product is the same. Remain same.
Okay. All right. Okay. All right. Okay. So you wrote here increase, decrease, decrease, and no effect. All right. Let's see whether it's correct. The temperature is increased. The effect of exo. This reaction is exo or endo, my dear? Zuhua, this reaction is endo or exo?
Exothermic.
So if you increase the temperature, what will happen? It will go up or go down?
Go down.
Yeah. So your first answer is wrong. Get it?
Yeah.
Okay. All right. The second one, concentration is decreased. You remove the HCOH, yeah, correct. It's not correct. Concentration of both is also decreased. Correct. Catalyst is removed, no change. Okay. Very good. You must be more aware of what you're doing, okay?
Okay.
All right. I'm going to show you one question that we just only did just now. Okay, we do together, all right? Some things you might not know. Okay, you read the question first. Okay, done reading?
Yeah.
Okay, so like this, huh? State what is meant by the symbol. This means, it's very specific. It means enthalpy change. Okay? The enthalpy change is negative. State whether the forward reaction is endo or exothermic. Zihua, endo or exothermic?
So
Okay. Okay. What is the temperature for Haber process I just taught you?
temperature it will decrease.
No, no, what is the temperature?
Oh,
Didn't you write down notes just now? What were you doing just now?
100
Huh?
degrees Celsius.
Zihua, I just taught you 5 minutes ago. What were you doing? Didn't you write it down? You didn't write it down? Then what were you doing? So just now the definition also you cannot remember because you didn't write it down. The temperature is 450 degrees Celsius. The pressure is 200
200.
atmosphere, but this is a different unit. This is a different unit. So then, if you don't write it down now, when I send you the notes, do you copy it? Huh? No, Zihua. I'm not asking you to write it down now. I'm asking you, when I send you the notes, do you copy it? Huh? Yes or no?
Yeah.
So you copy the notes after class, is it?
Yeah.
Okay. So 200 is atmosphere. For kPa is a different unit, it's kilopascal. So what happens is from this unit to this unit, you need to times 200. You need to times 100. Okay, you need to times 100. It's a different unit. So the catalyst is iron. Okay.
Okay.
All right. Do the same thing that we did just now for this. Are you done?
Yes.
Okay. What's your answer?
Decrease.
First one here is decrease.
Then also
Wait, 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 wait,
decrease.
wait, 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 wait. Temperature increases. Okay. Pressure decrease, is it?
Decrease.
Hmm.
Also decrease.
Hmm.
No change.
Hmm. Do you understand?
Yes.
Okay. Oh, sorry, this one, they're asking you why it shows it's exothermic. So it's because it's a negative value. Okay, because it's a negative value, it shows that it's exothermic. All right.
Okay.
Okay, so now there is another thing that we do other than Haber process. It's called contact process. Okay. Now, contact process is a four-part reaction. Okay, so in part one, next week remind me to next week remind me to go through the color change of anhydrous salt. There's one more part. So this is called contact process. Okay, contact process is to make sulfuric acid. So the first thing you do is the molten sulfur burns in air to produce sulfur dioxide. This is not a reversible reaction, it just burns. Stage 2 is the one that is reversible. Stage 2 is the one that we need to have temperature pressure catalyst. Okay, so stage 2 is sulfur dioxide gas reacts with oxygen gas. This reaction is reversible and it produces sulfur trioxide, which is also gas. The specific conditions for this is also 450 degrees Celsius, but we only use 2 atmosphere. However, the catalyst is different. It's V2O5, vanadium 5 oxide. Okay, vanadium 5 oxide. Okay,
Wait. Vanadium oxide.
vanadium 5 oxide.
Okay.
Okay, can? Now, after you make sulfur trioxide, this sulfur trioxide is reacted with, look at this stage 3, reacted with sulfuric acid to form something called oleum. Okay, so you react it with sulfuric acid and it forms something called oleum. Oleum is a very viscous, very thick liquid. Okay, this is called oleum. Finally, in stage 4, all you need to do is dissolve the oleum in water. Then you get sulfuric acid. Okay? Can? All right? Okay, so this is called contact process. Okay, this is called contact process. Contact process is used to make sulfuric acid. Okay, so why do we want to make ammonia and why do we want to make sulfuric acid? What is it used for? Okay, so these are two very important processes in the industry. Okay, so Haber process is used to make ammonia. This ammonia is then used to make fertilizer. Okay, fertilizer is also used to make cleaners and stuff like that, but most important is fertilizer. Okay, sulfuric acid is also used to make fertilizer, but it's also used to make a lot of other chemicals and also used to make batteries and solvents. Okay, can you understand?
Yeah. Wait,
Okay.
I'm copying real quick. Wait, so this one is always a 4-step process.
Yeah, to make sulfuric acid is a 4-step process, but only the second one needs temperature, pressure, and catalyst.
So the
Okay,
rest
the rest no need. The rest
Ah.
just react. It will react by itself. Okay,
Okay.
right. I will send these notes to you. Please remember to study. Okay.
Okay.
Bye bye.
Bye bye.